our needs, because we are so focused on here, run this query, run this command on this specific box over here because I'm using its state, because I'm mutating its state, a lot of that doesn't really apply to us. So gRPC web, go ahead, sorry.
Does this apply to all of JavaScript, just to the browser, or to all of JavaScript?
Yeah, JavaScript being a general purpose language doesn't have the limitation here. The browser has this restriction because websites can be malicious and can do bad things. And so we have to limit what the website can do to make sure it's not attacking services that you are authenticated for. So yeah, good question. So these restrictions do not specifically apply to other things like Node. If you were running a Node service, they don't specifically apply there. Some of them still apply because of how the JS clients for gRPC end up working. And I'll touch on that when we get to that, because that'll be a little different too. So gRPC Web dumbs everything down. It supports all the way back to HTTP 1.1, which means you can do just plain request response. However, that's totally useless to us because now we have no streaming. So we want to ignore that part of it. It has the potential to carry either binary or text protobuf payloads, but the implementation that is provided by the protobuf and gRPC team does not actually handle binary streams. So you can send binary data in request response, or you can stream text, but you can't stream binary. So that's a little annoying. And until the writable stream API is standardized in browsers, only server-side streaming works. There's no way for the client to send messages during a streaming conversation to say, hey, okay, now I'd like this instead, I'd like this instead. So you can't change the viewport once a subscription has started in the way that Arrow expects that we might do something like that. So what is HTTP 2 versus HTTP 1, just in case you're not familiar there? Instead of having one TCP connection per request response and then reusing it with Keep Alive, HTTP 2 allows multiple requests to be happening at the same time and multiple responses, and they can race each other. So you can say request, request, response, response, request, response. They can just go back and forth. There's some little marker on each payload to say, here's what I am a response to. They are stateless, which does fun things like you can have 10 different clients talking to Envoy, and Envoy can have just one single socket talking to the backend worker, and it sends all those payloads through that one socket. If you have 1,000 different clients talking to 10 different workers, there's still only those 10 different backend sockets that are open, and it's up to Envoy to figure out which message goes down which pipe to get to where it needs to go. This was important when we were considering how to do some of our WebSocket stuff back in enterprise. It still matters for the stuff we're doing in open source. It's going to matter more as we figure out how to do larger installations. The one really big thing, though, is once we get to, we have to use HTTP 2 in order to get streaming. It doesn't work in the browser without SSL. And SSL doesn't work without your browser trusting whatever certificate the server happens to be using. And this makes localhost development pretty difficult. We came to the conclusion that it's going to be just about impossible for people to click through any kind of a warning about this is a self-signed certificate or install a custom CA in general for most companies that people would be at who have a security team who says our users might not make the right decision. So instead of doing that, we had to say, okay, we can't actually use gRPC Web in the browser to talk to our client. So more on that in just a little bit, but that's a limitation that we have here, and that's one that we have not undone that workaround. We don't have a way to deploy properly with SSL at this time. So just a little more about HTTP 2 versus sockets, because the old enterprise client used to use a plain socket, and just depending on what your own background is here, what other clients you've had talking to servers and doing stuff. From an application perspective, each HTTP 2 stream is its own thing. If you make a request, you're going to get a response. It is totally unrelated to the other requests you have going. You can be authenticated differently for each one. If there were several tabs open for a single page or for a single server, they technically could be using the same stream, and they couldn't tell that each other was also sharing that. They could be using the same underlying socket, and they couldn't tell that other streams were taking place on that socket. But from a what are the actual bits on the physical wire perspective, these can be and probably are tunneled inside of a single socket, which means if that one underlying socket is lost, any of those running streams end with an error. But since the application now already has to manage its own session because it's handling all these different requests and responses, it can just restart those failed calls. So if the old Swing client were to lose its connection, that was it. That was the end of that connection. It could not reconnect and put things back together again because the other side said, well, it's gone. It's never coming back. The WebSocket wiring made the same kinds of assumptions since it was just sort of stapled on to the existing TCP stuff. But because we have to make the session not part of the wire format, but part of the application, we don't have those limitations in the open source version anymore. We are able to say, or we have to say, create a session just in case I lose connection to you. And then with every single connection we make, every single stream we create, say, here's the session I'm talking about. I'd like to keep talking about that session. And the server has to somehow be able to tell, well, the client hasn't talked to me in a little while. Are they dead? Or do I keep their state around for a little while longer just in case they come back? So by doing that, that means that if they do go away, if the connection does completely die, when the user comes back, starts reconnecting again, if the session has not died in the meantime, they still have all their objects, they can still reconnect. We have not implemented any of that reconnect in the current JS API, so the current UI does not reconnect cleanly. That's sort of a problem for tomorrow that we're going to have to deal with.
So is all this done with like session tokens or what?
Yes, we have a session token. We rotate it. We will talk about that a little more in the session service, one of the 4 services that we have, one of the 4 gRPC services. But you do create a token. Right now, authentication is just a no-op. You just say, hey, I'd like to connect, and it says, great, I'm happy to see you, super user. And then once you've got a token, you rotate it periodically. The server will provide some advice about when to rotate it. And as long as you provide that header, that metadata with every single request, that request is done in the same session you're in.
So the session token is passed as metadata for every single request you send. Wow.
Yes.
Okay.
Yep. Right, which sort of gets to the whole, it's built in, it's pluggable, it's automatically provided. It's pluggable in that there is a place to put metadata, but that's really all they provide for us. As far as I know, Nate, please correct me, but it sure seemed like there was a lot more there when you read the marketing material about gRPC.
Yeah, that's basically my interpretation is that you have exactly that. You basically get what the web has, which is like, a generic map.
Yeah, except cookies are built in.
And well, this is built
secure.
in too. Oh yeah, that's right. It's built in for some of the languages, and then it's really doesn't exist for others. Isn't that right? That's what you're actually saying in this case. I always forget. So Colin has this very negative opinion often, and it's often because of like the JavaScript support is so bad that he's seeing this like awful version of it, and like the other one, the Java versions, the C++ versions don't look so bad. But yeah, I see your point.
C++ doesn't have an interceptor though, right? Just like JavaScript.
They do have. They have. Well, yeah. So Arrow added a way of basically intercepting, and then yeah, it's not.
So it's application. You have to do the wrapping yourself.
Yeah, exactly. That's because C++ is a little bit harder with when you decide you want to do multi-threading. You have to decide on a whole lot of things, and so they kind of want to say, look, if you want to do multi-threading, the only thing we're going to give you is like a shared queue. And then you just pull off that, and then you figure out your own multi-threading. And we'll figure out our own, and we won't like worry about each other.
Yeah, JavaScript is not harder in that way because you get one thread, and that's it. Mm-hmm. A lot of these things are really easy to wrap. Functions are first-class objects. All you have to do is just put the wrapping there. But anyway. So because of a lot of these limitations, a lot of these issues, I found there's actually an alternative gRPC web implementation to use in the browser from another company who is using it. They can use the fetch API, which is a modern way to call the server, and it can fall back to XML HTTP request, which is HTTP 1, which we obviously can't use because we need streaming data. This still doesn't help for the fact that we want to do localhost development, or there will come a time when we have at least one customer who says, well, I can't get an SSL cert deployed I just want to use plain HTTP 1 with no certificate. And in that case, we have another alternate implementation provided by the same company, which allows using WebSockets. And what this means is you open a new WebSocket for every logical stream. We don't get to multiplex everything through a single gRPC, through a single sort of a high-level socket that everything would talk on, like it would in HTTP2. It's one WebSocket per stream. That way they can be individually killed and recreated. And you have to now run a separate proxy between your client and the underlying service. And in our case, that means you've got the browser over here, you've got the actual worker over here, we've got Envoy in the middle, and then there's one extra proxy that lives between these to say, wait for the WebSocket to connect. WebSocket passes through this proxy, which turns the WebSocket into plain old gRPC, and then past that, actually. They have discouraged using this in production. This is no longer the case. We are ignoring this at this time because we found we're not able to ignore that advice. We are going to discourage its use in production once we have actually tested a deployment that has SSL.
Where do we change these implementations if we want to change them?
The Docker Compose file is where the WebSocket proxy is enabled and where it is hooked up to say sit between the actual worker and Envoy. If you connect somehow to the Envoy server instance without trying to use a WebSocket, it should already correctly forward you whether or not you're using gRPC web, and it should automatically translate you to talk to the underlying service. However, if you don't have SSL, you can't do any of that from a browser anyway. So the next step then is we need to have documentation on removing that WebSocket and adding a certificate to Envoy as part of our Docker Compose setup. I'm hoping that the DevOps guys we're talking to right now who are helping us with some Google Cloud stuff are going to basically figure out how to do that for us, because that's something we just need some time to figure out. The JS API itself also has to pick a transport when it connects, and right now it says if I'm not HTTPS, let's fall back to the WebSocket. Otherwise, let's assume that I have all the power of HTTP2. So in theory, this will be transparent. The way we have set up the Envoy stuff so that it can be transparent, and it's possible we will recommend that people still use WebSockets, even if they're using HTTPS, just so they have the most flexibility. But there are supposedly some limitations when you start getting a whole ton of WebSockets connected at once. We haven't seen those yet, but we haven't gone digging. Okay, so that's sort of the background of the underlying technology we're using. And then, since I'm quickly running out of time, the actual services we've got here. Some of this is going to change. Nate will talk about that more on Thursday, I'm sure, or possibly interrupt me now. Several pieces of this are subject to change depending on exactly how we end up working these things out. So the session service, we've already talked about very briefly. gRPC has quote-unquote pluggable auth in the same way that all XML services are compatible with each other because they all speak XML. It's not very pluggable. It's just here's a place to put a token. Thanks. It's got to be a string. Sometimes you even get a little callback to say, would you like to change it this time based on something else? So we have to build our own wrapping in the JavaScript stuff. We built this from the perspective of Arrow, which is to say that all objects that you might interact with have an Arrow ticket object, and that provides us the ability to release a ticket. This service then provides us the ability to release that ticket to say I'm done using it, and to get information about what current tickets you have. For example, if you tried to do some work and you lost your connection before the work was completed, you don't know if that work is still pending or if it should be redone. There's also some possible questions about what the result happened to be. So the client might say, you know what, never mind that work, I'm just going to do it again. There's a lot of possible ways that things can go wrong, failure modes we've got to work out. The session is created with some very generic authentication wiring. Right now, it basically says anyone who tries to connect, if you just say I'm authenticating, it says great, you're a super user. Once you have a token, you have to refresh it periodically. And once you're finished with it, you can explicitly close it to shut it down. and release all of your resources on the server. Just to touch one bit on this ticket, Arrow itself does not have this release mechanism because from their perspective, tables are these gigantic static things that are just there. You don't usually want to say create a ticket, remove a ticket, create a ticket, remove a ticket. But from our perspective, you do, because you want to say underlying table that I just created, it's ticking away. Let's filter that in some way. Let's add some custom columns to it. Let's sort the result of that. Let's aggregate that. Wait, I changed my mind. I screwed up the filter. All right, undo all of these. Start again. Start building my whole chain of tables. Each of those intermediate tables potentially can have a ticket. We'll touch on more of that in just a moment. The Barrage service will probably be replaced with Arrow's own flight service, and our own subscription will end up getting folded into something they have called Do Exchange. But Barrage service for the time being is our own adaptation of Arrow's flight service with Barrage specific details. And Barrage really just means, it sounds like flight, except it's cooler. Flight is supposed to be, flight of an arrow. Barrage is a whole bunch of arrows. The streaming data is the part we're adding here to say.
Are you saying that Barrage is going away at some point?
The actual service called Barrage service will go away, and the Barrage functionality will be folded into some flight service stuff that's meant to be extensible. And I also have things to whine about the way that they do that, but I'm not going to do that right now because that's a little more Nate's area. The word Barrage will still apply. The underlying idea about what Barrage is will apply. We just won't declare a specific service for it. We will ask that consumers connect to a application-specific flavor of something in the existing flight service. This will make us look a lot more like Arrow to a consumer, which is probably a good thing. But it does make it difficult to say, hey, I happen to speak these different flavors of Do Exchange. How do I communicate that to my client? It turns out flight service looks like it should just be a generic API that anybody can connect to and can do some data transfer with. But there's so many things that are application specific or server specific that you really have to be custom tailored for that particular service you're talking to. It is our hope, I think, that we are as generic as possible. That way, anybody who can talk to anything resembling an Arrow flight service will be able to talk to us. But I'm not really sure how that's going to work. There are a lot of details that are just sort of arm waved that confuse me from the perspective of how would I actually connect to more than one specific flight service implementation. So flight service with Barrage will allow upload-download of static data, which is what flight naturally does, or ticking data, which is what Barrage adds. And wherever possible, we will cleanly interop with plain Arrow/flight processes. That way, if we have a client who only knows how to handle data that is static, we can publish static data for them, or we can publish a tool to say, call this one other method first. I will give you a ticket, which is now static, and it's the current snapshot of this other table, which was ticking. And now you can consume that, do things with it, and then when you're done with it, please release it, or just go away, and we'll clean everything up afterward. Table service is anything, that you could do to get a table will exist in this service as a call. Sort, filter, aggregate, flatten, anything that takes any kind of an input and returns a table to you exists here. Of those calls, any of those calls can be composed into a single call. So you can say, I want to filter, and then add a column, and then sort, and then aggregate that, and then sort that aggregation, and then join that to some other table over here. All of those can be composed into one big call.
Right. And you can
This
also
helps.
say, I only want like 2 of them to be exported.
Right. Only give me the final result of that. Throw away everything else, except insofar as the server needs it to build what I asked for. But don't give me the results afterward, because I'll just have to close them later. And you can also say each of those individual calls, you can fire them off one by one. You can even fire them out of order or before the actual input is ready. So you can say, even though you can make a call at one moment and say, please fetch this table, please sort this table, please filter this table. and each one is referring to the one before it, even though the responses haven't come back yet. As long as the request is tailored properly, those can all race each other, and the server will just spit out responses once it gets them. And it's technically true that any call that takes a ticket has this property where you can race them against each other. We have our session service takes care of this to say, even if I haven't seen a ticket yet, I will expect to have seen it within a minute or so. So you can make calls about it, and I will just set that call up in a queue. And once all of its dependencies are satisfied, I will start doing your work. For the old Swing UI, we ended up doing a lot of round-trip calls to do everything, and then we ended up building a lot of hacks to say, well, these 3 calls are often done together, so let's smush them into one big call, or just add a bunch of flags that turn on and off different features. The original version of the Open API had this batching mechanism so that you could say, get this work done on something which you don't even know about yet. And we've refined it a little bit for the gRPC service. Most of this, with any of the client libraries we build, should be transparent to the user, and it is assumed that the client UI, or the client library will correctly figure out what work it needs to do when. But this does make it a little harder for that client library to get it wrong. As long as you say, table 1, table 2, table 3 in this pipeline of operations, as long as they get fired off vaguely at the same time, you'll eventually get the results back for that final thing. So this is the primary way to get data back. This is what we want users to be interacting with, unless they are a console user. Running code directly on the server is great for user interaction because you understand the model of how you're writing code. You want to write your own little loop. But calls must be evaluated serially, even between users. And the asterisk here means eventually that won't be the case. But for the time being, if you have 3 different users connected to a server and they're all running Groovy or Python, and one of them makes a long-running call that downloads a bunch of data and processes it in a loop. Until that call is finished, nobody else can execute a call, and the LTM is locked. Nobody else can run things on the LTM. And this is a limitation of how we execute code, how the evaluation runs. There are things we can improve here, but this is something we've inherited from Enterprise. This is not something a limitation we've added ourselves.
But we can't
any UI interaction. Sorry, go ahead.
We can't have multiple workers in multiple sessions to do different threaded processes or something, right?
We definitely can have multiple workers, but it's server infrastructure that'll have to take place to say that here's the UI and here's the different workers that are running. How do I pick which one I'm connecting to? How do I know when to start a new one? There'll need to be some kind of process governing how many exist, things like that.
And that's not
we don't have that today. We don't have a plan for it either at this time. We do expect that this is going to happen and that we are going to instigate some of that, but it's also going to be, if we do a little too much work there, it's going to take some of the work that Enterprise is sort of better at, some of the management of a larger cluster. We do expect, though, to have create a worker, its job is to scrape data from this service. Create another worker, its job is to scrape data from here. Create a third worker, its job is to join these things. And then make 5 workers who expose all that data to our various users as they connect. And once a user picks a worker, it talks to that one for the duration of its session. But we want to sort of maybe round robin those users. That way there's lots of load to spare. So that kind of thing should be possible. We probably want to make it, I don't want to say difficult to put together, but we're not going to build the same kinds of infrastructure that we built for Enterprise to handle all of that. So if you are using the table service instead, however, almost all of its operations will not require that lock. So the preference should almost always be, as a client application, to avoid using console commands and just tell the server what you want. And it will take the lock when it needs it, but hopefully that will be for a very small part of the work it's got to do. So any UI interaction will flow through here. Most likely any programmatic access, whether it's C++, client that's feeding Python data, whether it's some other service that's trying to pump data into the system, whenever you click, the sort field in the console, you type some t equals whatever command. That is taking the LTM that is running in the Groovy or Python script session. But then when you click sort or you use the filter mechanism in the UI itself, that goes through table service instead. And that means you're not blocking other users from getting work done. Even if it's a sort that takes minutes, that will not block anybody else. Console service is where we have the actual, here's a blob of code, just run it. And there's no way to say, what is this code we're about to send? So naturally, there's some limitations we've got here and some concerns. Console service does the creating and interacting with the consoles, as well as autocomplete. Autocomplete can look at the other commands you've already run, the other data already in your session scope, and figure out what the possible autocomplete possibilities are there. Any currently scoped variable lives in the console service. Probably we're going to expand that at some point and move it somewhere else so it can be shared. That way you don't have to have a console to access scoped variables. That's just where it is right now. From an end user perspective, this is the most important service because when you do most of your thinking in that Groovy or Python console, you tend to think about the table API and how you interact with it in terms of typing and auto-completing those strings. From my perspective, this is a terrible idea, a terrible way to teach users how the system works. Because it is, while it's a great hammer and there's all kinds of things you want to hit, we do want to be more careful in real production systems about taking that lock. And also about the kinds of security implications of running arbitrary code. If every single client on your platform can run arbitrary Groovy, and some user figures out that they can just inject something in there and run some other arbitrary Groovy, the sky is pretty much the limit on what they can do once they're there. As a great example to that, there's a bug in, I think, sudo. Was it sudo? Something like that this past week. It's a 0-day. Anybody who can run sudo at all and can kill the command while it's running is able to run commands as any other user. So you can easily get yourself out of this little sandbox we've got. Even if we restrict you to only being a simple Iris user who can't access any data, because you can run arbitrary Java, you can access the runtime object, you can invoke commands, you can kill your own commands, and now you're root. So that's terrible. And we should make sure that when we present the various APIs to users, that the console is great for how do I integrate with data on a system where I am well trusted, but this is not the system that you want hundreds or thousands or external users to connect to. We don't have any ACLs in place right now in open source to make it hard to connect to this. At some point, I think we're going to need to switch like that to say only this kind of user can connect. So just touching on these limitations here one more time. Commands are blocked on other commands. They require the LTM lock, preventing some other operations from taking place. I believe that used to include when you made a subscription, how long it was till you got your snapshot. That may no longer be the case. And due to the dynamic and flexible nature of our supported languages, and that we run that requested code correctly instead of parsing it, figuring it out, what is exactly this operation? Is this something you're permitted to do? It's very difficult for us to analyze exactly what code you are being run. A malicious user could, I forgot to keep typing here. A malicious user can do any number of things. Can access stuff on disk that they probably shouldn't have access to, things like that. In theory, we have them nicely wrapped up inside a Docker container. In practice, Docker containers aren't actually all that. It's not a jail. It's just sort of a painted line to say, please stay in this area here. This is where you belong. So I'm a little bit over time. So I didn't go any further than that because I figured it'd be the case. Any questions about gRPC or how we are applying it?
I'm excited to learn more about the barrage because when I've been doing things, that error pops up sometimes. I haven't logged it to figure out more about it, but I'm guessing that's Nate next time.
Which error is that?
I don't know. I just noticed that when I do things wrong, I get a barrage error. and so I haven't logged why or when. Just know I did something wrong.
Okay.
So, excited for
Yeah, at least
details.
pop that in the chat when you see that. I can't think of anything specifically you should be getting on a regular basis there.
Yeah, I agree. I don't think there should be any barrage errors that are exposed to the users. Hopefully that stuff just works behind the scenes.
Sounds like it doesn't.
I'll try and take note of it next time I get it, because I don't know anything about barrage. So
Yeah, it might be one of the 3 custom types, potentially. I think, or there are only 2 now. I think there are just a few custom types that I haven't implemented on the Java side that Colin did implement on the JavaScript side, but nobody has complained about them not working. So I haven't prioritized adding them yet. But if you have a use case that's easy for me to test or something, and it happens to be that, I'm more than happy to fix. So definitely, when you run into an issue, something that you think works that doesn't work, yeah, put it in the chat, because it's, you know, it's no problem if it's a user error, and if it's not a user error, then everybody else fixes a problem faster, right? So,
And if it is a user error that's coming up with a terrible exception, we need to deal with that too.
yeah, right. And plus, the sooner you get the help that you might want, the sooner you get to do what you want to do too.
So who else in the company besides you two, so Colin and Nate, would be considered, I guess, the experts on this, how Deephaven uses gRPC, these different services you guys employ? Like, who else? Is it just the whole dev team, or are there a select few people who would be the people to go to for this type of knowledge?
Yeah, so I think I would actually say that both Darren and Christian have quite a bit of knowledge here, because they added some gRPC services for, is it for auth or config or both?
Config.
Config.
I think they were doing auth, but that never actually merged.
Right. I think it might actually have been merged in develop and now may have been removed from develop or something like that. But
right.
But yeah, so both of them know quite a bit as well. Not how we're using it on the OSS side. I think the OSS side, like a lot of the things that Colin has talked about, like those tickets and the idea of having exports depend on each other, is pretty unique to OSS. And it's an extension of what existed, as Colin said, on the Open API for the enterprise side. But the only piece of it that really thinks that is that part of the Open API side.
Okay.
Let's see, who else? You know, Colin? I mean,
I would tend to say Ryan also.
Yeah, Ryan has a good idea. Corey is definitely is now becoming more familiar with what's going on here, because he's actually hooking up, to the protobufs and the C++ layer.
But Nate or I have written just about every bit of gRPC we've got, and I have consumed most of it. From a client perspective, I'm probably the only client so far.
Okay.
Mm-hmm. Yeah. Well,
so we don't actually know that everything works, unfortunately, because we haven't been able to build everything out yet. Having at least one client be able to do everything is great. We really should have another 1 or 2 clients, and that was always the plan in Open API, and we never really got around to most of them.